All right. Okay, so for this week's task, what you will have to do is to implement some changes to the database you started working with. Right? So there were some things that were lacking in your first design. There were no constraints, so people could insert the same actor or movie multiple times. But when you submit for me on Monday, you should have fixed that so that those errors do not happen. The second type of error, if you look at our diagram, is that there's some relationship between the different tables. So the table for star and table for stars in. There could be a name of a star that is used in stars in. So for example, these are the tuples. So there's a movie star who has a name, and in stars in, that star name is being used. So we don't want someone to just go and put in that someone is starring in a movie when the name doesn't exist. Right? And that is accomplished using foreign keys. So part of this assignment would be, you are going to expand on your definitions, your SQL definitions for the tables, to include primary keys, and then foreign keys that will handle the references. So that when you use a word in one place, it should be referenced. It has to be in the other place before you insert. Okay, so question. Yes. Okay, so for example, just for this example, there is movie star, so that would be create table right. The movie star has a name, right, and it can be Vaka. I seem to like 200. You don't have to make everything 200. I seem to use 200 a lot. And that would be the primary key. Remember, the primary key is the one that, for the tuple format in the textbook, is underlined. Uh-huh.
You can access it in star name, but what if you type star name? What if you type a star name? Will it be added to the database?
No. Okay, so that's a good question. You see this in some database systems, well, the front end. In Microsoft Access, perhaps, that when you are picking, sometimes we go and insert it for you. But in this case, remember, we are dealing with the raw commands, insert, delete. These are specific commands, the dbms. So if you are trying to put somebody in the stars in table, I'm going to do it right now, just this small one. You realize that if you don't have a star, it's not going to work because there's no foreign key relationship.
If you were in that means that if you type a new star name in the stars in the stars table, it will give you like a drop down list of every member in the movie star.
That is with Microsoft Access. Here, we don't, in order to do that, that means you'd have to write the code. For Microsoft Access, they've already written the code, and it's more or less, I should say, I wouldn't say tailored at unprofessional users, but it's made to be very user-friendly without all the technical details. But,
So that means that every star name is a movie star.
every star name is a movie star, right? So that means when you are picking, so all the software you see where someone is picking and it gives a drop down, means somebody has written some code to go and bring all the stars so they can select. So for example, this is a movie star, so you have to do this for me on Friday, show me something. You can start early. I'm doing just 2 of them. You have to finish the remainder. Right? And you have a stars in. So create table stars in. Have movie title, which is string. Movie year, which is an integer. Some people use year as well. And star name. Right. And if star name and star are to be related, so if you look at this design very carefully, if the star name and star should be related, then at the very least you should make sure that the type, so if it's varchar 200 here, you should also make it varchar 200 here as well. It doesn't have to be that the name here has to match the name there. Right. And you see a naming convention in this where they write star name, and it means that go to some table that has star in it, and the name attribute. So if they write like movie title and movie year, you realize that there's some table called movie that has a title. There's some table called movie that has a year. Right? And so now, if you look at it, the primary key for stars in, that means that you're going to specify a movie what? Title. So let me just add that in. I'll run this code so we see what happens. So primary key is not just one item. If you are specifying primary key, if it's one item, you can do it this way. You can see that as I've done for this one name, it's just one item. That's fine. But if there's more than one thing in there, what you have to do is to list it at the end. So movie title, movie year, and star name. Right? So that means three things. Okay, so scroll up. All right. So some primary keys have just one column that you are using to identify the things in the table. Right. Example, for star, there's only the name that this database is using. Not saying that this is a very good design, but that is what we are using right now. Later, you would have we'll give you more opportunities to come up with your own designs. But currently, we are all sticking with this. Right. So the star name, and you can see from the tuple format that it's underlined, means that is the key. It's unique for every star, right? That one is the primary key, so we specify it here as primary key. That's one way to specify it. Another way would have been, the two ways to specify primary key. To say, after all of this, right, that the primary key is name. Right? Are people cool? So there are two ways to specify it.
Instances where you need a primary key composed of two attributes.
Yes.
Can you write primary key on the line of the two attributes, or you have to do it as a primary key brackets, name and gender?
Okay, so he's asking if the primary key. So if you look at the stars in, the primary key has three components: movie title, movie year, and star name. And he's asking, is it necessary to write it this way or this way? So this is one way. But if you do this, most dbms's currently would choke. They would say you can't have primary key defined twice when you put it on two different lines. So what we tend to do is, at the end, we would say primary key and then list the things that are the primary key. You can do the same if it's just one item. Okay, so question and then I'll take the lady. I'll start with the ladies on this. It's possible, yes. So remember, the primary key just means something that is used to identify. So if it's, for some tables, the primary key would just be almost everything, especially for the tables that are like in the middle, linking two things from each side.
I'm just wondering, for this class, is it okay to put the not now and now options?
Currently, I'm not enforcing people putting null and not now. But if we go further with design, you will have to ask what are the constraints. So if you're making a DBMS, you would have to ask, what are the constraints on this? And someone would say, oh, not now. If someone says not now, it means that it should never be now, right? And if that's the case, if someone is doing entry and they don't put in the value, it will refuse to accept it. So for example, if I were making a movie star and I added gender, not now, birth date, not now, it would mean that if someone is inserting data into this and doesn't have that information, it will refuse. But I have not asked that you put in that constraint now. But in later exercise, when I ask and I say, oh, this should never be empty, that should be a hint that you should have not now there. So that when someone is inserting and it's empty, they will refuse.
But there's no problem with having the now and not now options.
You can put not now there for this one. But just make sure when you do it that way, watch your insertions. Because if you put not now there, you try and insert and it's required, they will refuse to insert. Right. So there was a lady here as well. Okay.
What's the implication of having very high keys and does it have any effect on
Okay, so it's not going to have any effect on another table, but on itself, it means that you can't have the same combination of movie title, year, and star in that table. No, you can't. So I'm going to run this code after, but I'm taking questions now. So insert into, for example, stars in, and someone specifies it as a movie title. Movie year, star name. Values, maybe Bloodspot, 1998 or 1986. Hey. Okay. If I don't spell the name properly, do correct. Is it correct? Okay. All right. So someone can have this. Right. If there's another star, so the second one will not work because it's saying that the three things have to be what? 8. All right. So if I were putting it in, the first insertion will work, but the second one will fail because that combination. So what primary key says is that combination of things has already occurred. If I change just one of them, so if let's say I put in, okay, this will work because it's a different combination. The primary key means that the three things together are unique. So the first one is different from the second one. The first combination is different from the second combination. Yes. Okay, so remember that when you are designing these primary keys, often it depends on what your goal is. So let's take, for example, registration, student registration. Everyone has done registration, right? So if I had a student table, so maybe create table student. I'm not going to put everything, just a few things, right? Such as SID, which is an int, maybe a name. I'll just keep it very simple for the example. So I have these students, and I also have courses. So after this, I expect that you should be able to build what we have here. CID int primary key. And the name of the course. I've been using name, but please note that name is a reserved keyword. So why am I not using 255? As I said, it's just a habit of mine with the 200. When you are designing for a client, you have to ask and find out what the limits are. Right? So if, let's say, you were designing and you went to some country and someone said, oh, there's a field called, description. You have to ask, how long should the description be? And based on what they give you, you put it in. I just tend to write 200. I don't know, maybe it's my fingers on the keyboard. I tend to do 200. So I mentioned at the beginning of the class that I seem to have this affinity for 200. Maybe I should have had an affinity for 300, but I seem to be really 200. 1,000. I don't know. I don't tend to write 1,000 a lot. I tend to write 200. So, okay. So now, if you want to have course registration, let me finish this example and I'll pick it up. Or it's with this one. Okay.
I think this question is, it was asking of 55 precisely, and I think it's about the power. Yeah, and the thing is, why can't 6 more than 25?
For this, for MySQL, there are some dbms's where the limit is 255. So they use 255. But MySQL doesn't have that limit. Right? You have to check the specific implementation. It has been changing for a while, but I don't know what it is for the version 5.6. But usually, if something is about 1,000 characters, this was working. If it's getting very large, there's one called text, which would be if you have a whole essay, that works. And there's even, I think there's even one beyond text. I have to, you remember the
Microsoft SQL Server has the bracket size of
8,000. Okay. So as you can see, it varies from what? Implementation to implementation. Right. So your question.
Mm-hmm. When we give something like IDs to students and course for kind of like protection against maybe and for
so what you are seeing here is I'm giving just an ID integer, numbering them, right? But you can have more constraints than this, right? One of them, for example, is, okay, for courses, I can add unique, right? So the dbms will have many, if you go through each dbms syntax, there will be many rules that you can add in. So that means that you can have two students who have the same name, but their IDs are different. This current design, and this is similar to Ashesi's design. Your student IDs are different. It has to be different. But it's possible that two students of the same name can occur. I will tell you the kind of constraints, right? Or if I say come up with some of your constraints, that means you may have to research on the type of system you are building. If I said, okay, do something for postal service, you might have to go online, find out how does a postal service run, what are some of the constraints in there. Right? So, for example, if I ask you to make a school database, and then you didn't have any constraint on student ID, even though we all know that students must be different, that would be poor design on your part. Either you didn't do enough research, or you are not comfortable with the area.
What about the movie after school now?
Okay.
So over here, the primary key, the parameters are 3.
Mm-hmm.
Please explain why in this case there are 3 parameters for the primary key starting.
Okay, so I'm doing an example now that she asked about, and that would solve this issue, right? So the issue we are trying to solve now is, why is it that sometimes we need 2 things for a primary key? So this is an example. I have a student table and a course table. Now, if I were to implement this, and I'll run this in my workbench, because okay, I have to balance out the typing and the running. Okay, if I am to put in some student registrations, and I said, okay, I'm going to put in SID int primary key, and every time a student registers for a course, I would also like to record the course ID. Right? So there are a few options. For example, I could decide, maybe currently, for someone who hasn't done a lot of design, this could be his database. I'm going to run this and we'll do some insertion so we can see the issues that occur. Right? So if, just wipe down my whole, okay, good, it didn't go away. Right. So this is a student and course registration database. Very simple database. I'm sorry my interface is a little bit different from yours. My version 6 of Workbench keeps crashing. Might be something I'm doing. So I am forced to. Alright. Okay, zooming still works. So I have create table. This will be small when I do a query. Let me see if I can make this a little bit bigger. Format, preferences, SQL editor. I know there's supposed to be a size. Yeah, sorry, this version has okay. When the queries come, I'll copy out the data so it can be larger. So my apologies for this one. So I have first to create a student table that has been created. I have a course table. I create that, and I also have a registration table. Oh, further. Is it better? Okay. So I have a course registration table, and I run that one as well. So there are all these check marks, green check marks showing that it worked, right? I'm going to insert a student, so I'll say insert into, I had 2 columns, right? SID and name. Values 1, Kofi, that's my first student. Second student, Charles. Third student, it's intentional, okay. Amma. Should the first insertion work? Okay, so if I do this insert, that's working. Okay, what about the second insertion? Right, and why wouldn't it work? Right, because the ID has been specified as the primary keys, SID. So if I try and insert 1 Charles, this should, it fails. So the error here is duplicate primary key. Let me just see if I can copy this out. Copy row. Hello, just a sec, please. I was trying to copy the error, but it seems it's not okay. Maybe I have to switch between different editors, but let me paste it in here. Oh, sorry. Okay, so this is the error. Insert into fails, error code, duplicate entry. Right. So if you try and insert something where it violates a primary key constraint, it will fail. And as far as this design, so for example, on this campus, to ensure that we don't have two students with the same SID, that is the key. So that it doesn't matter what application you use. If anyone tries to send information to the database, whether from their web app or their mobile phone or anything, the moment it hits, it's going to refuse to put the information in. So these are some of the constraints that we're talking about that the dbms can do. Excel, you could probably try and pull this off in Excel, but I think it's much easier to do it here. Not to say that those who are selling Excel shouldn't keep on selling Excel, but every application has its strengths and weaknesses. Right. So for a dbms, one of the strengths is it's easy to describe some objects, add in the constraints, and the dbms does the rest of the work for us. You don't have to know how to code in Java or Python or anything. You can quickly put your data together. Right. So let's make the correction and continue. 2 and 3. Someone had a question from here. Kuna. The error message that came out, and you will see this as you work. Duplicate entry 1 for key primary. The user. Okay, so what happens is, when you make an application, right now we are doing SQL, so you see the raw error, right? But if you build a web app on top of this, right, that's a web app that sends a query, you can then take the error, read it, and then return to the user a user-friendly message. I hope you understand. It's just like Java when you do try catch. So you can see what the error is in the back end of your code, and then not have the user see this. But at the beginning of this class, we are actually working with the dbms. So we are not hiding any errors from you. So you can see the sorts of things that come up. Right. Okay, so I'm going to insert the other 2. Let's put those 2 people in there. So put into Charles and put in Amma. Right. Now I've put in some information for those. I'm going to put in some information for courses as well. Insert into course, the CID and name. Values, let's say course 1 is, okay, I'll use a different range of numbers for courses. 100 is CS, maybe CS111 into course CID name. Values 200, okay, 101 is dbms, it's this course. So I'm going to put 2 courses in there. And there won't be any complaints because the IDs are different. Now we are coming to the registration part, the part where we ask ourselves, what sort of primary key do we use? Do we use a single value primary key, or do we use what? A combination. So after we compare, we'll find out. Your question.
You see how you cannot treat a primary key from one item to another?
Mm-hmm.
In the same way, can you not, like 1 could be and then you write 2 could be?
You can add constraints in. We can add more constraints. I think you use the word unique. Something like, okay, I actually have it here already. So I have it for course. So watch what will happen if I try and put in another course that has the same course code. So this happens here too. Someone comes up and says, I want to have OS. Course. 102. That would work. Wait, that would still not work. Watch. Why won't it work?
You write 102, and yes, you use the DBMs.
Right? So why would this fail? So let me copy the error that comes out. So it actually has failed. So I'm going to copy out the error for this so you can see what it says. And the error message is based on copy row. It's based on what I have here. What did I say? the name is unique. So if the name is unique, that means that I can't put in, so duplicate entry dbms. Then you could. But for this one, I put one in there with unique, which forces it. So it's almost like a primary key, but it's not really a primary key. But you would realize that means that the ID would be unique. And also what? The names will be unique because I've added a unique constraint. Your question. Mm-hmm. Okay, so yes, you can make updates to this, right? So let me put in this one line. Let me make this 3. So on Monday, we did say we'll look at updating values, right? So if, for example, this also failed actually. Let me make it, okay, let me use an example that happens here as well. Suppose Amma comes and tells us she's not called just Amma, she's called Nanama, right? What we'll do is we'll say update student set the name equal to Nana Amma, where SID is equal to 3. Right. So that is how you'd actually go about updating the values. No, it's not going to overwrite. So some DBMSs are behaving a little. I should warn that depending on the DBMS, but currently in the relational model that we have here, this is not the case. But I've seen some DBMSs that are going to behave the way you're talking about. Where anytime you insert something, if it's there, it would put in. If not, you overwrite. There are some that behave a little bit like that. But this one is going to insist. So I can't have one. I can't even do one Kofi again. I couldn't even do one Kwame because the primary key is the SID. So it will prevent anything coming in. You can update to another. Maybe I could update a student ID that set 1 and make it 10. But I can't put in while it's seeing the values to add in something that will violate the constraint. So, question?
What are the names of the DBMS that add code and change the line of code, changes the database? So instead of having to update, you can just change the
I'm not understanding. Database is that?
the way this workbench releases the code, once it implements the code, it goes straight to the database. But is there a way where, as you're coding, when you make changes within the code you've already coded, it will run again and make the changes instead of constantly putting in new entries when you change?
Okay, so he's asking if we make changes to the code we are typing, can it automatically be sent to the DBMS? That's it, right? Okay, so right now, you can you can make an interface like that. That just means that you're going to create, and I think SQLfiddle.com has something like that, where you put in your create statement, and anytime you say run, it actually just looks at what you've done so far and initializes itself with the new data you have. Right? You don't have to drop tables or anything. Right? And that means that they have looked at a web interface, and anytime you make changes to the text, it will run everything again and make an update. Workbench doesn't behave like that, in that it waits for you to explicitly say what you want to execute. So there are 2 execute buttons. So it won't run a command until you execute. And there are good reasons for this. Maybe you haven't finished testing. It will be very annoying if halfway through you delete and wipe something. And Workbench, warning is if you try and delete everything from a table, for example, Workbench will refuse. So mine has been modified a bit. But Workbench, to delete something from a table, you could say delete from students where SID is 3. That means delete the person who is 3. But if you did something like delete from just student without specifying anything, meaning you are wiping everything. Workbench currently prevents you from doing this. It doesn't mean MySQL is preventing you. But what was happening was some people, after Workbench became popular, some people claimed they were dbms experts. And then they downloaded these things. And they would start running queries and start wiping off, updating, deleting everything. So as part of the protection within the system, to make you feel comfortable, Workbench, so for yours, if you try to delete everything from a table, it would give you a warning. You could drop the table, but if you try to delete everything without any like where this is this, it would actually just prevent it. There's a way to enable it again in preferences. But that's almost like if you have a phone and you want to maybe root it to do things that are overboard, or you want to run a program as admin, so it doesn't ask you any questions. But currently, Workbench, whatever you type in, you have to execute, so it sends the command to the database. Okay, so let's try and get to this part. So we've done a student table and a course table. In the student table, we've done some insertions. I'm going to display the information from the student table, so you at least believe that it's in there. Hello. They are almost the same. The only thing is for primary key, you can use it as a reference from one table to another. For unique, it's just within the table that it checks to make sure that it isn't repeated. Okay. So student returns 3 values. It's not very beautiful, but there used to be this feature called zoom. Okay, I'll find it. Trust me, I'll find it. Find it very soon one day, so that as I'm doing this, I can zoom in. So these are 3 values that I got when I did select star from student. Right. So my select star from student gave me Kofi, Amma, and Charles. Right. I'm just showing you that it's there. Not that I'm tricking you or anything. It's actually there. There's no secret. Right. I am going to also do select star from course. That means get me everything from course. And for that, okay, let me just copy the values out. Right. And that gives me these 2. Right. So if I want to register students, just as we do on campus, right, you have to think of registration as a process of recording which student is taking what course, right? You did something like this in programming 1, but let's do it again here. So what information do I need to record the fact that someone is taking a course? I need what? Which columns will I need? Or what information do I need to record? Like if you went to the registrar and said, I want to register for a course, he would ask you, which course, and then what? Your student ID. Even though she may ask you for your name, what she'll end up doing is she'll find the ID that belongs to you before she does the registration. Or if you have a web interface or some phone interface that you're working with, it may give you a nice description. Okay, Kofi Mensah, right, or Alice Wood. But when you click it, before it actually does the insertion, it's going to find the ID before it puts it in. Is everyone cool? I had a no somewhere. So if I said I was registering Kofi into dbms, what will I use for the CID? dbms is what? 101. dbms is 101, representing that specific course. And the SID Kofi was 1. So this actually means that, means dbms has Kofi, whose ID was 1. That's the information at the top. Right. Now, some people are asking, why is it that the primary key has 2 or 3 things being put together? Right. Now, consider this. What if I did something like this? Right. So conceptually, does it make sense to have these 2 rows? No. Right. So as part of dbms design, some of it is you have to sit and ask yourself, is it really a good idea to have 2? If you have these 2, imagine if you went to register and you think, oh, I clicked and dropped the course, and it tells you, well, you're still in the course. Like, oh, but it's saying that you're going to get a 0 because you thought you dropped the course, but there are more records there saying that you are in the course. That would be a little bit frustrating. So sometimes when you're doing a design, you have to look at it from what the user expects and how should the database behave in order to be consistent with our expectations. So our expectation is if we see a course ID and an ID for a student, that means that that student is in that course. We don't need to record it 2 or 3 times. Right? So if I wanted to register AMA in dbms, this would be, how would I need to change it? That means that AMA is what? Number 3. Right. And this is accomplished by making the 2 things what? The primary key. That if the primary key is CID and SID, then what we are enforcing will hold. So the stars in, if you look at the stars in, so it's a good thing we are talking about these stars. Right. If you look at the stars in, it means that you can't star in a movie more than twice, the same movie. So Van Damme can't be in the same, it's like cloned himself or somehow. So once it says Van Damme stars in Bloodsport, he's in Bloodsport. Right. I don't need to record it twice. Right. I hope people are understanding that one. Okay, so question from.
I guess that's part where you don't want to record twice. You're creating a primary key, but some of the primary keys were not ID. An ID is logical, right? An identity. So every person has one.
Yeah.
But some of them were, I think I saw, after the movie, for primary key, we have the movie star name listed as in bracket for primary key.
Yes.
So in the example you gave now, where you needed a CID and an SID. I mean, in that situation, you're just calling on the identities from various tables. But in this situation, you need the movie and the star.
Okay. So currently in the design that is listed in chapter 2, the movie table has a primary key that consists of a movie title and a movie year. Sorry. Which together are going to form the primary key. And that means that, okay, I haven't added foreign keys yet, but that means that for movies, it's not just going to be the title of the movie. We also want to know the year, and together that would identify the movie. Right. And so far, most of the time this works, but these days it doesn't work anymore. But even for now, it's unlikely that Avengers 2 would happen twice in a year. So Avengers 2 maybe, when was Avengers 2? Was it this year? This year, okay. So 2015 Avengers 2. 2015 Avengers 2. So we won't expect to store the same thing twice. Right?
Why don't you just give it an ID and work on this way?
Okay, so sometimes, right, depending on design, you can decide to give it an ID or not use an ID. It's not every single time that someone will make an ID. Sometimes things are easier to handle. So for example, if in this case, what you see is it's very easy to pull data and know exactly what you're dealing with. Right? If you have an ID, sometimes once you have the ID, you have to go and look up what else describes it. But for pure design purposes, if you have some columns that can represent the entity, some designers will just pick the columns that represent it. So if, let's say, there's a table and already there's a social security number, someone may just go ahead and say, we'll pick the social security number. If, for example, as I said, you have different buildings and different rooms. So someone could say maybe engineering block 101. It could be that the ID wouldn't be just numbers. It would be a combination of 2 or 3 fields that identify it. That is a design choice. But by doing this, he's also accomplishing the unique thing that he wants. Remember, the 2 things were supposed to be unique. So by making it a primary key, he's also more or less killing 2 birds with 1 stone. But a lot of designers these days have been using like ID, just putting IDs. But I should point out that this also has its strengths in that you quickly, within one line, capture the fact that something is unique and is also the primary key. Right. So you're going to see this one in this design because a lot of the fields that were listed, they actually went ahead and picked, so many. So I think it's Adobe Acrobat, okay? For this one, movie is one of them. Stars in is another, where you have to. So you realize that because movie was being used in stars in, if it was an ID, that means it would just have been maybe stars in, movie ID and star name. But because the movie itself has 2 things, that's the primary key. When it's being referenced somewhere, it's also being referenced with the 2 things. It's not referenced like halfway. It's referenced that, okay, these 2 things. So this star name, and the movie. But the movie wasn't just what? Movie name. The movie is identified by its name and its year. So the two things are put together. Now, expanding on this one, let me show you something, a design that at least real life, what happens on campus. Well, more real life, what happens on campus. What will happen is, we would also tend to have some year. You can change this design depending on the constraint. Suppose I told you that a course would run every year. That means that now this CID thing is not going to work anymore. Because that means if you register, God forbid you fail, can't register again. Right? But these days, people register, maybe he dropped the course and came back next year. Or he registered, failed and came back next year. Or registered, passed but didn't like the grade, wants to better. So in that case, what can happen is, we can make not here. Where's the course? Okay, course. The course can also have, right, so that the primary key is not just, okay, so this uniqueness has to go. So that now, every year, every instance of a course can be identified. CS111. Actually, it goes, it's year and the semester. So within the semester, we can't have, the other things may be children of the first thing, but within a semester, really there's just one course. We don't have two courses. There are different sections, right? But within a semester, there's just what? That one course. It won't be OS and OS. They are just subsections of the course. Are people understanding the point? Or no? Okay, so let's expand this to have foreign keys. Let's simplify back to where we were, and we'll add the foreign keys. Right. Okay, so someone is asking about simplification for, hey, did I remove everything? I better not have. Foreign key. Movie. Okay, so this is what we had. We had put in primary key for the student. We had put in primary key for the course. And for the course registration, our primary key we chose as SID, CID. Right. Now we want to put in foreign keys so that what? We constrain people. So you can't put in any fake courses, right? Or any fake registrations. Right. So what we'll have to do is we'll add foreign key SID references students SID. This is how you make a foreign key to the first table, and foreign key CID references course CID. What that will mean is within this course registration table, you cannot put in a student ID unless the student has been put into what? The student table. And similarly, you can't insert a course ID in this course registration table unless what? The course exists. Right? And you can see that when you first come on campus, you'd want to take a course, but sometimes it would say, if we don't have all your registration details, I don't know, some freshmen went through that, where maybe the first list came and other lists are being loaded. And so if your name hasn't been put in yet, you are not even on the schedule. And same for new staff, I guess. When you first come, you are not going to assign a course if we haven't put in your staff details. So you get an ID and we can say, this course by this staff member. Right. So for a lot of systems, this rule is applied. If you make a foreign key, it means that you have to put in some data in the parent table. In this case, you need a course before what? You can put in course registration.
So, how does the system work to ensure that when we put in a course, it has to have already been put in the course in comparison with the SID?
Okay, so let's copy this and put it in. Usually for most systems, there are a lot of queries that happen in the background. It's just that since we are, well, more or less in the back end, we are running the commands ourselves. Though for someone who made his own web application or system, he can make things a little bit more automated, where in one form you fill everything. Is it crying for battery power? Crying for battery power. Is it's done well today? Wow, that's a big vlog. What is that? Okay, charging now. All right, so we are going to add in the course registration. Oh, did something... Oh, it already exists, right? I'm just going to drop the old one and put this one in. Did I drop it? And then create the new course registration table. Okay, so there's a new course registration table that's been created. Now, if I wanted to register a new student, so if I have a system where there's a page to add a student, that means that on that page, it's going to be required to run some insertion code. So here you can't just what? Insert, let's say there's a new student coming whose ID will be 4, who is called Thompson. I can't just go and say, okay, I'm going to put in insert into course registration, some SID, CID values for, and, oh sorry, that's SID, and then maybe into dbms, so I'll say 101. This is not going to work because, let me just run it, you see that. So I'll copy out the error so you can see what the error means. Error says. Right. So the error here is insert into cannot update child row. Key constraint fails. So anytime you try and put in something into the system and it needs a value from another table to cross-check against and it doesn't find it, it's going to give you an error. Right. So if you build an application that's running, it means that you may have to do, so when you come on campus, definitely we have to what? Add you into the student table. For staff members, we'll add you to the staff table. But the courses have to be created. And then what? Finally, so to fix this, that means I have to, some people encounter this. So to fix this, that means I have to what? Insert somebody. I need SID and name. Values maybe 4 and Thompson. I need to make sure a student is in that table before I carry on with. Okay, so insert, and then now course registration, hopefully. Now, everything worked out well. Right.
My problem is how does your simply adding these foreign keys match, like, how does matching work? Because we just said these are foreign keys.
Okay, so that means that before it inserts, so the rule is simple. If there is a table that has, and in this case, the table has, okay, I'll just select start from course registration. Right. Okay, this is not a, let me do print screen. Let me just snapshot this and make it big. Open in an image editor, like, hopefully this won't crash. Okay. No, this isn't the image editor I would have really liked. Yeah, this, sorry, I think I have to work more on this laptop until I figure out what I've installed. Okay, let me start again. Copy this. Copy to clipboard. Sorry. New, come on, be good, be good, be good. Okay. So in this case, I have what? 2 fields, SID and CID. So what the foreign key constraint means is they can be null. So for foreign key, if something is null, they won't complain. Right? So maybe it's a value that is not required. Primary key means it's going to be required, so it's going to go and look it up. But for foreign key, it can be null, unless there's a primary key constraint on the column as well. So it was a primary key. So in this case, SID, CID is both a primary key, that's together, and individually the CID is going off to the course table, and SID is going to the SID table. Meaning anytime you insert or update, it's going to have to check to see that the rule that the SID here corresponds to some student always holds. So if it checks and realizes that after doing that insertion, or after doing that update, there will be a conflict, right, going against the constraint that you have set, it's going to refuse that insertion. I hope you understand. So if you are doing an update as well, if I try to update someone's course registration to a course that doesn't exist, it's going to what? Refuse that update if it can't find a course in the course table. So foreign key is going to check. So the constraint is check to make sure that the person you are referencing, so in this case, the reference rule here is, was a reference rule we wrote down, that SID references students' SID. Meaning any value that's going to be put in here is going to go and do that check. Or if you are making an update, so someone can say, oh, what if I put it in and later I change it to something else? That is also going to fail. Right? Same for the CID. If I put in something, if I try and update it to something else, it has to check to see, is there something that is in the course table that has the same ID? So that is referential integrity. And that is accomplished in this case with foreign keys. Right. Okay, so there's a question. That's a very good point. Yes, so if you're running it in this mode, I know there are some commands which you can send to the dbms to tell it to ignore the constraints for a while. I've forgotten the command, but I'll find it. But, or if you want, you can just search online and see. There's a command that will disable. But the moment, so it's a temporary measure. You disable it, you can enter all the data in any order that you want. But the moment you enable it, it's going to what? Go back and check the rules that you have put in. Right. So whether temporarily or not, it will always make sure. But for assignment purposes, if there's one table that depends on another, so in this case, the course registration table depends on the course table. Create the course first before you create the course registration, so you don't get an error. Because the moment you tell it to go and do foreign key references, it's going to complain. It's going to say, well, it doesn't exist. I know that some people have designs like that, but in a good, well-normalized, so when I mean well-normalized, it means well-planned out, all references are made. It's highly unlikely to have just one table standing there. It can happen, but usually we'll ask you, like if we enter your dbms and there's just one table hanging there, usually we'll ask, how can there be just, unless maybe what you are capturing now is just one thing. Or maybe you have a database management system and inside you create a database with one table. If that's what your constraints or your requirements say, that is fine. But for me, it's a little bit odd to just have, for example, if you say I'm going to design a university database and the student table is just sitting there, not referencing anything. Your first instinct is, how can this be in a system where things are interacting? It's very rare. If you see it, you should look closer. If it's true, you leave it alone. But when I see things like that, I look closer. Like, oh, okay, you're telling me that there's something accounts. Why is account just sitting there? It doesn't connect to anything. It just sits in a corner with values. You'd have to wonder, or you wouldn't. You'd wonder, how does this relate to the entire system? It's highly unlikely. In a company, almost anything you pick, there's some relation. If you pick accounting, some relationship. Languages, the new department, there's some relation. It can't just be by itself. That means that maybe the design isn't finished, or someone hasn't done all the links. It's highly unlikely. Mm-hmm.
And in some way, I'm guessing that it's related to the movie table. But there's no, unless I understand, there's no existing relationship that connects them. You have to create a relationship.
Okay, so for chapter 2, there's a chapter 2 section where it describes this. I was hoping people have already read this one, but in chapter 2, it describes the different tables there and their relationships. So just read it up. I believe it should be tied to movie, but was it movie studio? But read just to check, to be sure. Because there's some relationship that is missing. That right now it's standing alone. It has a number, certification number. You can't do, I don't think the hash, those who are doing, the hash won't work for a column name, did it? Okay, so you have to use set number. Right, and it's here as well. Press, I think that this and this, but read to be sure. Read to be sure. Because the movie execs had to control the movie studios. I believe that it's this person, this press. So check, just read the description to check. In the chapter 2, every single table has a description. Just read carefully and implement accordingly. Okay, so the stars in here is actually a relationship. It's a relationship. Okay, so that's why that question I asked you last week, as to why some things have what, even though they are relationships, they are also tables. And in this case, yes, stars in, it doesn't have an attribute in the ER diagram per se. But when you come to the relational model, it does have certain columns or attributes. So the view also matters. In this view, this is the high-level conceptual view. In the back end, you don't worry about, okay, it has all these. But because there are all these links, somehow you have to capture that information. And that is why when it becomes a table, you have this extra information representing the arrows that are going up and down. Okay, so when you're doing the redesign of this one, if you realize that something is missing, so for example, the movie exec is missing, that means that you have to draw an entity and then add a relationship when necessary. Okay, so he has asked another question, which is, do we need to have movie title, movie year in this diagram? Okay, so some of them are implicit, right? The fact that stars in is connecting this and this, it means that implicitly, stars in will have some information from both people. So it's implied. It's implied. Yeah. You will not. Okay. So for the relationships, this is what you should watch for the relationships. A relationship in this high-level diagram. So note that for this design, there are two parts, right? The first is the very high-level design. At the high-level design, you are not worrying specifically about every single column in your table. You are concerned about capturing the description of what is in the system, right? So you have here that stars in movie, but you don't need to have in the stars that stars needs to have an attribute called movie star, or it is implied by the connection, that line, right? So if it's a relationship, often those attributes that are helping to define a relationship are not specified. So you have, for example, studios and movies. I don't need to have on owns a movie ID, or in this case, movie title, and movie needs a name. Okay, well, that was the title. Movie title and year. I don't need to add it to owns, because the line connecting owns to movies implies that what? There's going to be some transfer of attributes in order to make it happen.
So when I create the set and this definition between that and studio, I call it heads, for example, it doesn't have to necessarily be in the attribute of state definition. For example, stars in the state setting, like that, but owns is not there.
Yes, so you have to add the ownership to it. You have to add the relationship in.
So I have to do that.
Okay, so for I think you will need a new table in order to accomplish this. The same way that stars becomes a new table. Stars. So if exec is not in there, so here you can just say what's the word, like movie exec owns or runs, whether it's a movie or a movie studio. Okay, take it. Relationship.
And to you, the hash at the set can be added to it, so find out how to do that.
So the hash, you can add it in. I think I've mentioned something here before. So, all right. So we've done with the first part of the course. This today. I'll just give 5 minutes break, and then we'll come back and do the diagrams. Right? So 5 minutes just to relax, and then when we come, I'm not going anywhere. In 5 minutes, I'll draw the diagram for students taking a course in both dia and then workbench, so that you can do the same for me on Friday.